Okay guys, so I'm going to be filming the transformations. I'm trying to fix the camera angle a little bit here. Give me a minute. Alright, so this is number 9A on the review. So we're going to talk about transformations. Now you're going to be provided with a formula chart on your test. And here's the formula chart you're going to get, the star reference materials. And if you look at the bottom of this chart, you're going to actually see that there are formulas for reflections, translations, rotations, and dilations. Now, how do you read this chart? I'm going to film in a different video to kind of show you how to read it, but I'll give you a short rundown here. The translation is the easiest one. That's the one where you're just sliding the figure left and right. So in a translation, you're basically going to take whatever XY coordinate you have, and whatever it has after the X, you're going to do that to every X coordinate. So it says plus in. If that said -7, you would be subtracting 7 from every X coordinate. If this says -4, you're going to subtract 4 from every X coordinate. Because all of your figures have multiple coordinates, right? Your vertices. If you're looking at the Y coordinate, this means that whatever is here plus M. It could be +9, -7, +4. Whatever it says here is what you're going to do to every Y coordinate. So for example, if I have a point that is 1, 2, and I want to change this to x -3, y +1, what I'm going to do is I'm going to take this 1, the original, and I'm going to subtract 3 from it. So 1 - 3 is -2. So I'm going to do that to every X coordinate for all the points on my figure. The Y coordinate is 2. This says y +1. I'm going to add 1 to every Y coordinate. So 2 + 1 is 3, and that's your new point. So that's how you do the translations. When you look at the reflections are just counting, but if you want to look at the reflections here, again, I'm getting my fun little markers out. I've got reflections here. So for the reflections, x-axis and y-axis. If it's over the y-axis, notice what changes. The x just changes sign. So if it was positive x, it becomes negative. If it was negative x, it becomes positive. That's it. Okay? If it's over the x-axis, the y changes sign. So remember, this is your x-axis and this is your y-axis. So if I use the x-axis as my mirror and I take a point here and I flip it over the x-axis, my y value is going to change sign. So if I was at +2 and I flip it over here, it becomes -2. If I flip over the y-axis, my x value is going to change. So if my x was at 6, it's going to become -6. Or if it was at -6, it's going to become 6. So that's how you do the reflections. The rotations, these are the fun ones. These are the ones everybody tends to struggle with. On the rotations, you're just going to read. It tells you to take the original coordinate and then it tells you over here what to do with that coordinate. So if this is x, y, and you're rotating 90 degrees clockwise, what you're going to do is you're going to take the y and the x that you had here and you're going to flip them, because this now has the x written over here and the y written over here. Then you're going to take what this x was and change its sign. So if it was positive, it becomes negative, etc. If you go 90 counterclockwise, you're going to take the original point, x, y, and again, this has y and x flipped, so you're going to flip them to get to here, but now you're going to change the sign of whatever the y was. So if that was 4, it becomes -4. If it was -4, it becomes 4. For 180, if you look at the 180, you take the x, y. The x and y don't change places. There's no switching. The only thing you're going to do is switch their signs. Okay? 270, you're going to take your original x, y. Once again, you can see these two did switch. So the x and y switch places, and what was y becomes opposite. So that's how you do the rotations. Okay, so you're just going to follow the formula chart on the rotations. With the dilations, which is the last one, sorry, I'm trying to do this with one hand and my markers are not cooperating with me. The last one that you'll do is the dilation one, And if you look at the dilation here goes from xy to kx, ky. What the dilation is you're going to multiply all the x's by the same number and all the y's by the same number. That's it. Okay, so using this, let's come back. I'm going to be doing transformations here. I'm going to be doing a translation first. This is triangle JFK is here. Rotate the triangle 90 degrees clockwise. So as you're going through this, we're going to use green for rotations. As you're going through this, you've got these 3 points that we're going to change, okay? And you can see they're written out right here. We're going to rotate 90 clockwise. So you're going to go to your formula chart and you're going to look up rotate 90 clockwise. And what does it tell you to do for 90 clockwise? We're going to take the x and the y and we're going to flip them, right? So let's do that first. So since this was, 3 and 3, it's the same thing. We're going to have 3 and 3 again. That's boring. We're going to flip them all first. This becomes 2, 3, and this becomes 2, 2. I don't know why we were given the same numbers. It probably should have been different numbers. Then, after we flip them, what do we change the sign of? Whatever is in this second slot now, whatever the original x was that we flipped over, we're going to change the sign. So this one becomes a negative. That becomes a negative. That becomes a negative. That is your rotation. Okay? So let's look at the next one. The next one on 9b is also a rotation. Sorry, I'm trying to, my screen is not really all that dark. Okay. So, or not really all that light, I'm looking at my screen. I'm going to rotate this point 270 clockwise. So, I'm so sorry about all this. I'm kind of working in a cramped space here. 270 clockwise, okay? So if I look at the formula chart here, this has a 270, and this is going to be clockwise, okay? So this is going to be 270 clockwise. By the way, if that's not written on your formula chart, that should be. It should say clockwise. If I'm going to rotate 270 degrees clockwise, that means I'm going to take my x and y and do what with them? Flip them first. So let's flip them all over. Let's flip it. So instead of 3, -4, I'm going to have -4, comma 3, right? But then what does it tell you to do with your y value? Opposite it. And again, this doesn't mean negative, guys. It means opposite. So I'm going to take the opposite of what's in front. Well, that's -4. What's the opposite? 4. And that's your answer. So now that's +4, 3. Let's look at this one. Rotate this point 90 clockwise. Okay, come back to 90 clockwise. 90 clockwise means you're going to go from x, y. Once again, x and y changes place, so we're going to flip. So I'm going to take 4, 2. First step is to change it to 2, 4. Okay, and again, we're 90 clockwise right here. And then I'm going to opposite my second number, which was the first number. I'm going to opposite that. So since that's +4, it becomes -4. So that's how you do those rotations, okay? So let's look at 10A. 10A, we did these in class. This is a translation. Now a translation, remember guys, translation is just a lateral move. And I think on translations I used a blue, so we'll use blue. Translation is just a slide. Left or right, up or down. It doesn't rotate. So if I have the letter C, it's going to move this way. Just kidding. It's going to move this way. It can move up and down. It can move diagonally back and forth. But it's not going to flip over. We're not going to have a C pointing that way or anything. That's a reflection. Translation is just up and down, diagonal, left, right, pointing the same way, same direction. So I'm going to use this rule. Now, how do I apply the rule? The rule tells me what I'm going to do to each one. So I have x + 4 and y - 2. That's telling me I'm going to add 4 to every x coordinate. So let's look at our original picture right here, and let's plot points. X is at 1, 2, 3, 4, -4 because I'm going to the left, and down 1, -1. Remember, all points are x, y. That's point X. Point I is located at 1, 2, 3, negative 4 over 4, down 1, 2, 3, negative 3. Point E is located at 1, 2, 3, 3 over, 1, 2, 3, 3 down. So now I'm going to apply my rule here. What does my rule say I'm going to do? My rule says I'm going to add 4 to every x, and I'm going to subtract 2 from every y. So let's do that. So I'm going to take every x coordinate and I'm going to add 4 to it. Okay? So my new x and my new I and my new e, remember those little apostrophes just mean image, that means the new one. Negative 4 plus 4 is 0. Negative 4 plus 4 is 0. Negative 3 plus 4 is 1. Those are all my new x coordinates. Now let's do the y's. I'm going to subtract 2 from all the y's. So negative 1 minus 2 is negative 3. Negative 3 minus 2 is negative 5. And negative 3 minus 2 is negative 5. So those are your new points. So the translation, all you do is follow the rule. Now on 10b, you're actually going to write the rule. So on 10b, we're going to start off with the pictures and actually have to figure out what our rule was. So we're going to do something with x, every x, and something with every y, but we don't know what yet. Okay, it says which rule describes the transformation that was used to form this figure. Remember, the apostrophes mean that that's the new one. So this is our new guy. That's our image. Our old guy is our pre-image. This is the old guy. So we went from here to here. And so the question is, how did I get from there to there? So let's count. All you have to do is pick one single point. Just one. I'm going to pick T. T is right here. Okay, this T looks like it's about at 2.5. So T looks like it's about at 2.5. It's over 2.5, 1, 2.5, and then up 1, 2, 3, 4, 5. So that's my old T. My new T here is at 1, 2, looks like negative 2.5, and it's down 1, 2. So I have to figure out, how did I get from old T to new T? Well, we can look and figure it out by looking at these points, or we can just count. Let's count first. Well, first of all, where did I move? I moved to the left, which means what? There's going to be a subtraction. The x's are going to get subtracted because I shifted left. If I were to shift right, then I would have added. And then where did I go? I went down. I went left and down. Down means up and down. We're going to subtract from y also. So you can eliminate all answers that don't have subtractions. So what did I do with my x's? I'm going to count. 1, 2, 3, 4, 5. I moved to the left 5 places, and then I went down 1, 2, 3, 4, 5, 6, 7. So there's your answer. I subtracted 5 from all the x's, subtracted 7 from all the y's. So that's how you do that translation piece. Okay. So I'm going to do the reflection here, and then I'm going to film the dilations in another video. So we got one more video to go here. Okay. All right. Or one more problem to go on these transformations without the dilations. So let's look at this. We're dealing with reflections. Okay. Now reflections should be fairly easy. Now if you look on your paper, your formula chart, you've got the reflection formula, right? It says if I reflect it over the y-axis, the x changes sign. Everything else stays the same. I take the original point and I just change the sign of the x value. Remember, this means opposite, not negative. If I reflect over the x-axis, I'm going to change the sign of the y-coordinate. So let's look at this one. I'm looking at this picture. Reflect this one over the x-axis, okay? So reflect it over the x-axis. Guys, x-axis is here. That means that is your mirror. I always write the word mirror because it says x-axis right here. I always indicate that's my mirror, so I know I'm reflecting. All you do is count. This point is 1 above, so this point would be 1 below. This point is 2 above, so the new one would be 2 below. And you can connect them. This point is 1, 2, 3, 4 above, so this one is 1, 2, 3, 4 below. This one is 1, 2, 3, 4, 5 above, so this one is 1, 2, 3, 4, 5 below. And there's your reflection. And then all you have to do is you have to just look at the graph and determine what the coordinates are by using your XY. Okay? 11b, if we reflect 11b, the y-axis, that means this is my mirror. So I'll do this is my mirror. The y-axis is for A, so let's look at A. Now I'm going to reflect across this mirror. This is 1, 2, 3, 4, 5 on that side, so this one will be 1, 2, 3, 4, 5 on that side. So my new point here is at 5, 1. And if you look at it, it was at -5, -5, 1. All I did was flip the sign of the x coordinate, which is on your formula chart. Now let's look at C. C is reflected across the x-axis. So now for C, this is my mirror. Okay, so C's right there. So if C is 2 below, it's going to end up being 2 above my mirror. And then for B, B is also over the x-axis. So B is over here. B is 2 above, so its reflection would be 2 below. Okay? And that's how you do those transformations.